Guys, welcome back to Chemicals TV. In this video here, we want to focus on capacitors and capacitance in JAMB physics. Now, capacitor and capacitance is one big topic in physics that you are required to cover if you really want to perform very well. Now, there are some important topics in JAMB physics that you are supposed to cover. If you know that you have not covered those topics, now I have a playlist on JAMB physics. Now, by the time you finish watching this video, please go to those playlists and go and watch this video on those topics you have not actually covered. It's very important. And I've also done how to cover JAMB physics in 5 days. So if you have not watched that video, please make sure you go watch that video and follow the instruction. Do you understand? But in this video here, we want to look at what's capacitor and what capacitance of capacitor. Then you look at the definitions, the two main formulas you can use to solve problem under this aspect. Then we want to look at how to calculate question when it comes to capacitor connected in series and capacitor connected in parallel. Just that I can solve problem on that. They want to look at various type of questions, ways and patterns you see questions under this aspect here. Now, once we finish that here, we want to look at energy stored in capacitor. So we have to look at 3 key formulas when it comes to energy stored in capacitor. We're going to solve problem on that. So that we want to go to cover in this class here. So this is going to be an intensive class that will help you cover this aspect very well. I promise you, this is going to be one of the best videos come across when it comes to capacitors and capacitors. So that is why you want to build your pen, your notebook, and your calculator to follow through this video. But because of this video here, I'm going to give you some questions you have to solve. Make sure you solve these questions. Now, why you solve this question is it makes you understand the more. Unlike some places that will just see questions, they will not solve it and you go like that. You don't do that kind of student. When you say a question, you will not be able to solve it. So as I'm solving, I'm also give you the one for you to try, so that you can master it on your own, because it feels good when you solve questions and get the answer. So you solve those questions, you leave those questions, you leave those answers at the comment section, then I will respond to that. If you're not subscribed to the channel, please endeavor to hit that subscribe button and turn on the notification icon, because after the jam, you see I have a lot of content coming your way. So let's get into it. So what is capacitor? What's capacitor? Capacitors are devices used to store electric charges. So those devices that is used to store electric charges are called capacitor. So then what does have by capacitance of capacitors? Capacitance of capacitor is defined as the ratio of charge stored in the capacitor to the potential difference across the plates or between two plates. So now capacitor is the energy. So capacitor is a device to store electrical charges, right? Then the capacitance is C equals to Q over the potential difference. It's very important here. So this is quantity of charge stored in the capacitor. Then we call the potential difference. This is called capacitance. Capacitance, now therefore, the unit of this one is called coulombs. It's called coulombs. Why do you call volts? It's called volts. Now, the unit of capacitance is now farads. So you can have microfarad, farad. You have you can have 1 microfarad. 1 microfarad is 1 microfarad. And the prefix of micro is 10⁻⁻6 farad. So now when I say 1 microfarad, I also say 10⁻⁻6 farad. Do you understand? They also have 1 nanofarads. So which we call 1 n farad, which also is 10⁻⁻9 farad. Do you understand? They also have 1 picofarad. 1 picofarad, we also know as 1 p farad, 10⁻⁻12. 10⁻⁻12 farad. So there are things you need to take note of here. You have to take it down. You get, because I'm going to make it of it. Now, before we move into calculation here, now we have to call Capacitance of what? Of parallel plates. Capacitance of what? Of parallel plates. Capacitance of parallel plate is what? Is C equals to E A over what? D. Capacitance of what? Two of parallel plates is what? E A over what? D. Now C is what? Is the capacitance. E is what? Is permittivity. E is what? Permittivity. Permittivity of what? Of the material. Permittivity of the material. A is what? Is the area of overlap plates. Area of the overlap plates, which is what? M square. Then D is what? Distance between the two plates. Very important here. So they are the two key formulas you need to know. This and what this, and we have to use to what source or key question for move to what capacitance connected in series and what and parallel. Just so let's get into some questions. Okay, now let's look at what these two calculations. So let's look at what these two calculations. After I solve this calculation here, I'm going to give you the one for you to what try. Just understand. So it's that a parallel plate capacitor of capacitance 750 microfarad has a potential difference of what? 2000 volts between each plate. Calculate the charge on either plate of the word capacitor. It's very easy here. So if you want to such kind of question here, is that the capacitance is what? Is C equals to what? 750 microfarad. Do you understand? Of course, micro is also saying that what 10 is what? Minus 6. So you're going to be what? 750 times 7 minus 6 farad. So because you cannot use to solve like this, so you have to convert microfarad to what? To farad. And micro also is saying that what 10 is what 6. Do you understand? Now my V is what? My V is what? Is 2000. Do you understand? What I say to calculate the charge stored in the what? In capacitor here. Right there. I know that C equals to what? Q over what? V, right? So if you should what? Make Q the sort of formula here, Q is going to be what? C what? Times V. You get? So in picture of value here, W equals to what? C is what? 750 times 7 what? Minus 6 times my V is what? 2000. Right? So it will be 750 exponential minus 6 times 2000. So you have one. So my Q here is going to be 1.5 coulomb. That is the what answer. So if for example I change here to be what? To be 550 coulomb, and I change it to 1. I change it to be 4000. So what will be the answer here? So leave the answer at the comment section. So for the what first one here, leave the answer at the what comment section. So let's look at what question 2. Let's look at what question 2. Let's look at question 2. It's a parallel plate capacitor of area. So the area is what? Is 10 cm cube. 10 cm square. Right there. Now in a vacuum as a capacitance. So my capacitor here, which is C, is what? My C is what? 10 to the minus 2 microfarad. This is that. What is the distance? My distance is what I don't know. Then my permittivity of the material is what? Is 9 times 10 to the minus what? 12 what? Force per meter. Right there. Now this one is already what? In meter. Then I have to convert this one to meter. Right there. Remember, 1 meter equals to what? 100 what? Centimeter. Right there. 1 meter equals to 100 centimeter. So now because here is already square, so you have to square this thing. Just I have to square this thing. So what do you mean here? It means that here we have 1 meter square. Also saying that what? 10 is what? 4 centimeter what? Square. That is it. Just that because 100 is also saying that 10 is what? 2, right? So if you should square it here, also saying that what? 10 is what? 4. You get? So this is the conversion unit I'm going to make use of. So 1 meter square, you also say 10 to the power 4 centimeter watt square. Just because normally 1 meter equals to 100 watt centimeter. So it's square, you have to square both of them. So if you release bracket here, remove bracket, this is what I'm going to get. So it means that if I'm converting centimeter square to meter square, it's going to be times. Now, centimeter be like so going to be 10 to the power 4 centimeter watt square. Then you have 1 meter watt square. Centimeter square because I was centimeter square. So it will be so if you check very well, now because if you check this thing, now 1 meter square over what 10 to the power 4 is also the same as what 10 to the power minus 4 meter watt square. This is that is the same thing here. So this one is also the same thing here. So it's going to be 10 times 10 to the power minus 4 meter watt square. Can you see that? So this is what we are going to use here. So 10 centimeter square, you also say that 10 times 10 to the power minus 4 meter watt square. Do you understand? Now, this guy here, remember you have to convert to what to farad. Convert to what to farad. If you convert to farad, what are you going to get? 10 to the power minus 12, 10 to the power minus 2 times 10 to the power minus 6 farad, right? Now, which one are we going to use here? We have to use what physical formula, which is what C equals to what E A over what D. Right there. So they call permittivity of the material, area times distance, right? Now we are looking for distance. So make it D the solid formula here. You're going to be what D equals to what E A over what C. So let's increase our parameters here. So it's going to be 9 times 10 to the power minus 12 times A is what? What is my A? My A is what? 10 times 10 to the power minus 4 meter watt square over my C is what? What is my C? My C is what? 10 minus 2 times 10 to the power minus what? 6 watts farads. This is that. So we have to use our calculator to get our what answer here. This is that. We have to use our calculator to get our answer here. So let's use our calculator here. 10 exponential what? Minus 12 times 10 exponential what? Minus 4 divided by exponential minus 2 times exponential minus 6. So the answer here is going to be what? D equals to what? 9 exponential minus what? 7 meter. So if you use your calculator to get your answer or punch your values here, this is what you're going to get. You get. So and this is what is correct there. So that what I'm going to do, I'm going to change these things here. I'm going to change here to what? To 13. 13, and I'm going to change here to what? To 50. It's okay. So go ahead and try this one for me. Pause the video. Go ahead and try this one for me. So you have to try this one. You have to try this one here. Endeavor what you leave your answer at the comment section. Just now. So level to what the next one here. Capacitance in what connect in series and what and in parallel. So that is going to be the next thing. So now let's look at what series and parallel arrangement of what of capacitors. So now let's see how they are being arranged both in series and what and parallel. So let's start with parallel connection. So this is how it be arranged. So when you see a connection like this, it's not what parallel connection. Then when you see connection like this, now what a series. So now in a parallel connection, the equivalent or the combined capacitors is given as what? C1 plus C2 plus C3, depending on what numbers of capacitor given to you. Do you understand? So if it's three capacitors like the way it is 1, 2, 3 here, you sum them together in parallel connection. So the capacitor, the combined capacitance of capacitor when they are being arranged in parallel connection like this, you should just sum them together. You get your equivalent or your combined capacitor. Do you understand? And C1, C2, C2 are all the same. They all have the same potential difference. So there. So they are all at what? C1, C2, and C3. They are all at the same potential what difference. So they all have the same potential difference. So the same potential difference flows through them. Do you understand? So C1, the potential difference is V. C2, the potential difference is what is V. C3, the potential difference is what is V. Do you understand? They all have the same. Then the total circuit charge is when you sum them together. So the total circuit charge is what when you sum them together when it comes to what parallel connection. So please don't pay close attention to these things here, because these things are somehow, instead of just to ask you the calculation aspect, they might be asking you all these things here in your examination. Now let's talk about series connection. In series connection, yeah, because that the positive end of one connected with the negative end of one, just like this, right there. So the equivalent or combined resistance C is what? Is 1 over C equals to 1 over C1 plus 1 over C2 plus 1 over what? C3. Do you understand? Now, but if it's just two capacitors, if it's just two capacitors, the capacitor is going to be what? C1 times C2 over what? C1 plus C2. Do you understand? You have to technical of this one here. If it's 3 and more, do what we want to use here. If it's not just 2, instead of going through the stress, just multiply 2 of them and divide it when add 2 of them. Do you understand? You get this one here. Another thing I want to take note is that total circuit voltage is equal to what? V1 plus V2 plus V3. So the total circuit voltage is when you will sum them together. V1 plus V2 plus what? V3. That is, C1 will have his own votes, C2 will have his own votes, C3 will have his own what? Votes. Sum them together. Do you understand? Capacitors C1, C2, and C3 are all have the same charge. Do you understand? So also they have the same what? Charge. So look at the difference here. Now here they all have the same potential what? Difference, but here they all have the same they all have the same what? Charge. So you need to what? Take note of this one, the series and what the parallel what? Connection. So the next one to look at is what is the calculation aspect. So let's look at what various calculation aspect in this what? Capacitance and capacitor calculation. So let's get into it. Now let's tackle some important. So let's tackle some important questions. We have question 1, 2, 3, and 4. So these are what different ways questions will be asked in the exam. So you want to pay close attention. So look at what the first one here. They say that what is equivalent capacitance of a 6 microfarad capacitor and 9 microfarad capacitor connected in parallel. So remember, when capacitors are connected in parallel connection is what? Is C equals to what? C1 plus C2 plus what? C3 is okay. But here we only have 2 because we have 2. So my C1 is what? Is 6 microfarad. C2 is what? Is 9 microfarad. Right? So you are adding 2 of them together. Do you understand? So when capacitors are being connected in parallel, you add what? Them together to get what? Your combined capacitance. Do you understand? So it's going to be C equals to what? 6 microfarad plus what? 9 microfarad. It's okay. So you add them together. Here we have what? Here we have 6 plus 9. Here we have what? 15. So it will be 15 microfarad. Do you understand? As easy as that. It's not that too difficult, right? So let's look at the difficult ones. They say that 3 capacitors each of capacitance 16 microfarad are connected in series. So when capacitors are connected in series, they say 3 of them. So when series connection, right there. In series connection, you're going to have 1 about C equals to 1 about C1 plus 1 about C2 plus 1 about C2. It's okay. Now, there are the 3 capacitors each of capacitance 16 microfarad are connected in series. So my C1 is what? Is 16 microfarad. My C2 is what? Is 16 microfarad. My C3 is what? Is 16 what? Microfarad. Do you understand? So guys, I will draw in picture here. So going to be 1 about C equals to 1 about 16 plus 1 about 16 plus 1 about 16. Right there. So the LCM is going to be 16. Going to be 1 plus 1 plus 1. Can you see that? So it will be 1 about C. So 1 plus 1 plus 1 is 3 over what? 16. Do you see that? So it will be 1 over what 6 equals to what 3 over what 16. So making C the subject of formula here, here we have what C equals to what 16 over what 3. So 16 divided by 3, what will be what 5.333 is okay. So let's be like microwatt farad. So the equivalent resistors is what is 5.33 watt microwatt farad. So you can see how it is here. So you can see the difference between what parallel and what series what connection. So let me move to what question what 3. But now let me change this here so that you try this one for me. So what about if I have here to be if I have here to be 5 and I have here to be 10. What is the equivalent resistor here? So you have a comment section. If I have here to be 18, what is the equivalent what resistor? So leave the answer at the word comment section. I want to hear from you. Leave the answer at the comment section. I want to hear from you. So let me go to question what 3. Question 3. There's supposed to be a value here. There will be a 20 volts. 20 what volts? Yes, 20 what volts. So let's go to question 3. Question what 3? They say that the diagram above shows 2 capacitors, capacitor P and what capacitor what Q of capacitance 16 microfarad and what 10 microfarad. Find the charge stored in what P and what Q. You guys find what the charge stored in what P and Q. Now, yeah. Now remember in what in parallel connection here, the same voltage. Each of them have what the same voltage. Just if check very well. In parallel connection, the voltage here also the same here. Just so if you look at what the formula here, remember capacitor equals to what C equals to what Q plus what V, right? Now what I ask you to look for is what is the charge. If you mention the charge, if you mention the formula, you go to the Q equals to what C times what V, right? Now they're asking you here, find the charge stored in P and Q. Now in parallel connection when it comes to capacitors here, they all have the same what potential what difference. Just they all have what say what potential what difference. So the potential difference here is not the same to here. Do you get that? So here going to be for P so going to be what QP going to be what CP times what V. Just then Q what QQ here going to be what CQ times what V. Can you see that? It's very important. So that is why I gave you those things here. That's why I gave you those notes when it comes to what series parallel what connection. That's why I gave you those things. Get so yeah, my CP is 12. Remember here we have what 10 is what 10 to the minus 6, right? Farad times that's going to be what 20 volts, right? Same to here, you're going to be what 10 times 10 what minus 6 farad times what 20 watt volts. Can you see that? So what will be the answer here? So here we have 6 exponential minus 6 times 20. Here we have 1.2 exponential minus 4, right? The unit is what? The unit is what? Coulomb, right? So you do that one here. Here we have 10 exponential minus 6 times 20. Here we have 10 exponential minus 6 times 20. Here we have 2.0 exponential what? Minus 4 what? Coulomb. Do you see that? So this is what is the answer to this other one here. So you have to take note of this other one. So you say that Calculate what the potential difference across this one here, across C1, C2, and C3. Now, yeah, how do you calculate the potential difference across the question 4? But before I go there, let me change one here so that you try some for me. And let us say we have 50 volts, and here we have 10, here we have 12 microfarad, and here we have 16 microwatt farad. Okay, try question 3 for me. It's okay. So P have 12 microfarad, and this one have what 16 microfarad. So you go ahead, you try it for me. Just go ahead and try how to solve this one for me. Leave your answer at the comment section. So I'll give you number 1, number 2, and number 3 for you to try. So let's go with question 4. How do you answer question 4? How do you answer what question 4? So if you look at question 4, here we have these are connected in series. Let's say calculate the potential difference across C1, C2, and C3. Right here. Now the potential difference across C1, C2, C3 will be different if you check connection in series. Right there. The potential difference across C1, C2, C3 are totally different. So they're not the same. So instead, how do you calculate that here? Remember, you have C equals to what? Q over what? V, right? Now, what I want to do here now is to calculate what the total what is. What I want to do here now is to calculate what the total what charge. So if I can get what my total charge, I can easily get what my volts in what across C1, C2, and C3. Here's what is my total vote. Here's my total vote here. But it's not the same vote I want through all of them. So I have to calculate everything. So I have to calculate the vote that is here, the one that is here, and the one that is here. And for me to be able to do that here, I need to look for my total charge. So to calculate total charge here, you're going to be what? Q equals to what? C times what? V. Is okay. So what does it mean? That is total charge equals to what? Total the equivalent capacitance times the total what? Volts. Do you understand? Now, these ones are all connected in series. I will now say calculating the equivalent what? Capacitance. Calculate what the equivalent capacitance, which is going to be what? 1 about C equals to 1 about C1 plus 1 about C2 plus 1 about C3. This is that. So it will be 1 about C equals to 1 about C1 plus 1 about C2 plus 1 about C3. Can you see that? So my C1 is what? Is 2. So it will be 1 about C equals to 1 about 2 plus 1 about 6 plus 1 over 3. So what is the LCM here? The LCM here is going to be what? 6, right? So it will be 2 going to 6 is what? 2 going to 6. Because if you look at the LCM here, the LCM is 6. Do you understand? 2 going to 6 is 3. So it's going to be 3 plus 1 plus 2. So what now going to be answer? 3 plus 1. So it's going to give me what? 6. Right? So it's going to be what? 1. So my 1 about C equals to what? 1. That is my total capacitance is what? Is 1. My total capacitance is what? Is 1. So I'm going to what my total capacitance here. Do you understand? So my C is what? 1 microwatt farad. Total capacitance here. Now remember my total voltage V. My V is what? What is my V? My V is what? 12 volts, right? My C is what? 12 what? 12. So my C is what? Is what? 1 watt microfarad. 12 what? Volts. So now again, I'm looking for what my Q here. My Q total. Q is what I'm looking for. Do you understand? So it's going to be remember, yes, yeah, I'm going to change the what to farad. So it's going to be 1 times 10 to the minus 6, right? Farad. You get. I'm not finishing. See how here. So yeah, so going to be what? Q equals to C times V. So it's going to be 1 times 10 to the minus 6 times what? 12 what volts here. Here we have farad here. So 1.2 exponential what? Minus 5 is okay. Which is going to be our column. Going to be column. So this is what my total what? My total what? Charge. My total what? Charge. Yes. So now remember, they say I should calculate the potential difference across C1, C2, and what? C3. So potential difference across C1 and C2 is very easy. So if you should what? Make voltage sorry formula here, because they say what? Calculate what the potential difference across C1 and C2, right? So potential difference across C1 and C2, right? Potential difference across C1 and C2. If you should what? Make it sorry formula. Now the next thing you want to do is calculate PD across C1, C2, or C3, right? So yeah, let's make V the subject of formula. If you should make V the subject of formula, here we have what? V equals to what? Q or what? C. Can you see that? V equals to Q divided by what? By C. So that means I'm going to have what? V1 equals to what? My V1 is going to be what? Q over what? C1. This is that. Now my V2 equals to what? Q over what? C2. My V3 is going to be what? Q over what? C what? 2. Can you see that? Because say what? Potential difference across what? Across the capacitance C1, C2, and what? C3. So going to be what? Remember my Q is what? 1.2 exponential what? Minus 5 column over C1 is what? 2 microfarad. We're going to be 2 times 10 to the minus 6 watts. Minus 6 farad. Can you see that? The same thing here. 1.2 times 10 to the minus 5 over, here we have what? 6 exponential minus 6 watts farad. The same thing here. Now the same thing here we have what? Here we have 1.2 exponential minus what? 5, right? Column. Yes, column. Yes, column. Over what? Over 3 exponential minus what? 6 what? Minus 6 farad. So what you want to do now is to punch your calculator and get what? Your various what? Answer. And get what? Your various what? Answer. So here we have 1.2 exponential minus 5 divided by 2 exponential what? Minus 6. So here we have 6. So you're going to do what? 6 what? Volts. So here we have 1.2 exponential minus 5 divided by 6 exponential minus 6. Here we have what? 2 what? Volts. And here we have 1.2 exponential minus 5 divided by 3 exponential minus 6. Here we have what? 4 what? Volts. Can you see that? So we have answered question 1, question 2, question 3, and what? Question 4. You get? So if I should change here to what? To 15 volts, and here we have 5, 6, and what? And 7. So what will be the answer here? So do question 1, question 2, question 3, and what? Question 4 for me. Now, if this video is helpful, please leave a comment section that this video is helpful. If you're not subscribed to the channel, kindly hit that subscribe button so that you will not miss out every other video I'm going to upload when it comes to what? Your educational content. So please try to join the community, share this video to your friends if this video is what? Helpful, and I'll be grateful for that. So the next thing is going to be, the next one is going to be energy store in capacitor. Energy store in what? In capacitor. So that will be the what? Next thing. Energy was stored in what? In capacitor.